So read this question. In this question, a neutron, a proton, an alpha particle, right? A neutron, a proton, and electron, and the alpha particle, He plus plus you can say, right? Enters in the perpendicular magnetic field as shown in the figure, right? This is the magnetic field, suppose. All right. So you have to recognize which is the particle, either A, B, C, D, right? If you consider the neutron, what is the charge on this? Say 0. So if the magnetic field is still present perpendicular to the into the board, so if you consider the neutron, so neutron is not experienced any force by the magnetic field, so it will go undeviated. So which is that particle? C. Are you getting or not?
Yes.
Now if you consider the proton, this is the proton is H plus, the electron E minus, the He plus mean He plus plus. So if you consider this the electron, the minus E charge, it is plus E charge, it is plus 2E charge. You understand or not?
Yes.
So if you apply the Fleming left hand rule, this is the magnetic field, this is the direction of the velocity, so this is the direction of the force acting on positive charge. So on positive charge, right, the force will act upon this, so the negative charge force upon this in this direction or not?
Yes.
So it is positive, and it is positive, the electron is negative. So another charge particle which is called the D, right? So can you recognize the D particle is nothing but electron?
Yes.
Are you getting? Now there are two charge particles are giving. This is the one which is known as A, and this is B, whose radius is more. A radius of A is less. Are you getting or not?
Yes.
So what is the radius formula? Radius is nothing but mv upon qb. Are you getting?
Yes.
So they enter with the same velocity, mean velocity and magnetic field for A and B both are same. So radius is proportional to what? Mass by charge ratio.
Yes.
Right? Yes. If helium is, hydrogen is H, so its mass is M and it's 2He4. The He plus plus alpha particle is nothing but nucleus of helium atom, so its mass is 4m. Are you getting or not?
Yes.
So if you consider the proton and radius of alpha particle ratio, so mass by q ratio of proton, mass by q ratio of alpha particle, right?
Yes.
So what is the mass of proton? M. What is the charge on proton? Say E, right?
Yes.
Mass is 4m, charge is 2E. Are you getting or not? So what, when you will calculate this, so what the answer you will get? 1 by 2. So proton radius is alpha by 2, or alpha particle is the 2 times of radius of proton.
Proton.
So if you consider this is the small radius, right? So this radius is just double. So it means this is the proton, right? Because if proton radius is r, so the alpha particle radius is 2r. So it is alpha particle. Are you getting or not, you tell?
Yes.
So in this way, the A particle is assumed to be proton, right? The B particle is the alpha particle, C particle is nothing but neutron, and D particle is nothing but electron. You understand?
Yes.
Copy this. So read this question. In this question, three charge particles, proton, deuteron, and the alpha particle, right? The proton mean H plus, the deuteron mean H plus, right? It is proton, right? Its mass is m, its mass is 2m, and its mass is 4m, and it is the He plus plus. The charge is plus E and plus 2E. You understand or not?
Yes.
Right. Are projected in uniform magnetic field, transverse magnetic. Find the ratio of their radii circular track if they are A, if speed is same, right?
Yes.
So if speed is same, the radius is mv upon qb. You understand or not?
Yes.
If they are thrown in the perpendicular magnetic field, so and the speed is same and magnetic field is same, so what is the radius ratio proportional to q by m? So now you can think the radius of proton, radius of deuteron, ratio of radius alpha, m by q proton, m by q deuteron, m by q alpha. So m by q proton, m divided by e, deuteron 2m divided by e, alpha 4m divided by 2e. So it is 1:2:2. So this is the ratio of the radius of the proton, deuteron and alpha if the speed is same. You understand this?
Yes, sir.
Copy this first. So in the B part, if momentum is same, so the radius is what? mv upon qb. The p upon qb. The momentum is same, magnetic field is same. So radius is proportional to charge. Right? Radius of proton, deuteron and alpha particle. Proton, right, deuteron and alpha particle. So what is the charge of proton E, deuteron E? It is 2E. So it is 1:1:1 by 2, or you may write 2:2:1. Right? It is proton, deuteron and alpha particle radius ratio if momentum is same. You understand or not?
Yes, sir.
What is the third part? When the kinetic energy, that is ek, is same, right? So in this case the radius is mv upon qb and the kinetic energy is what? Say half mv square, right? Multiply by m and m, right? So it is m into v, 2m into ke. So 2m into ke is equal to mv whole square. Root 2m, kinetic energy is equal to mv. So radius is proportional to root 2m into kinetic energy upon qb. Is it clear or not, you tell?
Yes.
Now if kinetic energy is same and magnetic field is still same,
Yes.
k same, b same, so radius is proportional to root m upon q, right? So radius of proton, deuteron, alpha particle,
Yes.
mass proton, deuteron, right,
Yes, sir.
alpha particle. So what is the proton? Root m upon e,
Yes.
root m upon e, 4m upon 2e, right?
Yes.
So this is equal to what? It is 1:√2 is to root 4 upon 2. 1:√2 is to 1 because root 4 is 2. This is the ratio, right? Copy this. So now the fourth part is what? Say in the fourth part, accelerated potential is same. In the D part, if accelerated potential VACC is same, or delta V sometime it is same, right? So the radius is what? Say mb upon qb, and the mb can be written as 2m into kinetic energy upon qb,
Yes.
and kinetic energy is what? Q into delta V.
Delta.
Delta V is nothing but accelerated potential, so Q into B, right? So what is same? Delta V is same and the B is same. So root m q upon q, root m by q. Is it clear or not, you tell?
Yes.
So radius of proton, deuteron and alpha particle. The m by q ratio of proton, m by q ratio of deuteron, m by q alpha particle. Is it clear or not, you tell?
Yes.
So the mass of the proton is m e, mass of the deuteron is 2m e, mass of the alpha particle is what? Say 4m upon 2e, right? So it is 1 is to root 2 is 2, 1 is to root 2 is to root 2. This is the answer, right? Copy this. So read this question. In this question, 3 charged particle again, proton, deuteron and the alpha particle, right? That is H plus, right? And this is H plus also, the mass is 2, and this is He plus plus. M, 2m, 4m are the masses, E plus E and plus 2 is the charges. First, they are projected in uniform transverse magnetic field in such a way that their radii of circular track are equal, right? Then you have to find the following ratio respectively. First, the speed ratio, right? Speed ratio. So radius is what? Say mv upon qb, right? So radius is same. So speed is what? qb into r upon m. Is it clear or not?
Yes.
The magnetic field and radii are same. Speed is proportional to q by m. So the speed of proton, speed of deuteron, speed of alpha particle, right, is equal to q by m of proton, q by m a deuteron, q by m alpha particle. The E by m, E upon 2m, 2e upon 4m. So this is 1 is to 1 by 2 is to 1 by 2. So it is 2 is to 1 is to 1. The speed of proton, deuteron and alpha particle ratio is this. You understand this or not, you tell?
Yes.
Copy this. So let's see the B part. What is the B part? The momentum ratio we have to find, right? We have to find. If radius is same, is equal to mv upon qb, p upon qb, right? So what is the momentum then? qb into r. The radius is same, magnetic field is same, so the momentum is proportional to charge q or not. So momentum of proton is to momentum of deuteron is to momentum of alpha particle is equal to charge of proton, deuteron, alpha particle. E is to 2e, 1 is to 1 is to 2. This is the answer, right? In the C part, what they are asking, the kinetic energy ratio.
Kinetic energy.
This ratio they are asking if radius is same, right? In every question, radius is same. So what is the radius formula? mv upon qb, and the kinetic energy is nothing but half mv square, right? It is multiplied by m and m. So 2m into kinetic energy is equal to what? mv whole square. So mv is nothing but 2m into kinetic energy. Q into v root 2m into kinetic energy. Is it possible or it is clear or not, you tell?
Yes, sir.
So radius is same, magnetic field is same, right? QBR upon QBR is equal to root 2m into kinetic energy. So Q square B square R square, right? So kinetic energy is what?
Q square upon m.
q square b square upon r square upon 2m. So b are same. So kinetic energy is proportional to q square upon m. Right? So kinetic energy of proton, deuteron, alpha particle. Proton, deuteron, alpha particle. E square upon m, E square upon 2m, E square upon 4m. Right? 4 upon 4, it is also 1. 1 by 2. So 1 is to 1, because E square by m will cancel out, is equal to 4 upon 4. So it is 1 is to 1 by 2 is to 1. It is equal to 2 is to 1 is to 2. This is the answer. Right? And what about the fourth part?
Potential.
Potential ratio we have to find. So in the D part, the radius is 2m into kinetic energy upon qb. And what is the kinetic energy? Please tell. Q into delta V upon qb. So delta V ratio we have to find. In this case, delta V means potential difference ratio. Potential difference ratio we have to find. Right? Such that radius is same, the magnetic field is same. So it may be written as r square q square b square. Right? If you multiply r qb, 2m q into delta V, make the square. 2m into q into delta V. So delta V is what? R square q b square upon 2m.
2m.
Right? So b and r is same.
Yes.
Q by m. Is it clear or not? So delta V of proton, deuteron is equal to q by m proton, q by m deuteron, q by m alpha. So E by m at 2e by 4m. So E by m cancel out. For deuteron it is 2m. You will remember this. Right?
Yes.
1 by 2. So answer is 2 is to 1 is to 1. So this is the answer. Right? Copy this. So read this question. In this question, proton and electron are projected in uniform magnetic field. This is the proton and this is the electron. Right? And then trajectory of which charge is more? Trajectory of which charge is more curved? Mean the radius, whose radius is more? From its initial direction, if there, the A part, the speed is same. The radius of the ratio of their radius they are asking. This is the proton, the plus E charge, electron minus E charge, mass is me, mass is proton mass, electron mass. So whose mass is more, proton or electron? You tell.
Proton.
Proton mass. If the speed is same, whose deviation is more? That is whose, wait for 1 minute, wait for 1 minute. If this is the plus q charge,
Yes.
and it is thrown with velocity v, right? If its radius is this, are you getting?
Yes.
And if this is the plus q and this is the more v, so this is the more v. Are you getting or not? You tell.
Yes.
Which particle is more deviated? You tell.
The second particle.
No, the first particle is more deviated.
Okay.
How? Deviation mean if it is going in the same straight line, suppose this is the one particle and this is the another particle. So whose deviation is more? You tell.
The first.
First. and therefore its radius of curvature will be small,
Small.
and less deviation mean the radius of curvature is more,
Large.
right? This is the first thing. So if it is proton and it is what? Electron, speed is same. So in the A part, the radius is mv upon qb. The speed is same, v is same, radius is proportional to mass by q. So radius of proton and radius of electron, mass of proton divided by E, mass of electron divided by E. Are you getting or not?
Yes.
mp upon me. Proton mass is greater, so it is greater than 1. rp upon r is greater than 1. rp is greater than re. Proton radius is more, electron radius is less. So it means electron is more deviated. Understood or not?
Yes.
Copy this. So in the B part, momentum is same. So radius depends upon mv upon qb. So p upon q into b. Are you getting or not? Momentum is same. Listen, charge on each particle is same and magnetic field is same. So whether it is electron or whether it is proton, so radius of electron and proton both are same. Are you getting or not? Because the momentum is same and magnetic field and charge E and minus E magnitude is same. So radius of the curvature is same. So both have same deviation. Is it clear or not, you tell?
Yes, sir.
What is the C part, you tell?
Yes.
What is same in C part?
Momentum.
No, in the B part the momentum is same. In the C part what is given?
Kinetic energy.
Kinetic energy is same. So radius is what? Root 2m into kinetic energy. I think you understand this,
Yes.
right? mv can be written as kinetic energy is, I'm writing this side, half mv square multiply by m and m. So 2m into kinetic energy must be equal to m square v square, right? So kinetic energy is same and b same and charge is also same. So r is proportional to root of mass m.
Yes.
So proton mass radius and electron radius is proportional to mass of proton and mass of electron. Tell me, it is greater than 1 or not, you tell? Right? So rp is greater than r. Radius of electron is less, right? So therefore electron is more deviated, right? What about the fourth part?
Accelerated potential.
Okay, so if you consider the r, accelerated delta v is same. If accelerated potential is same, delta v is same. So radius is nothing but root 2m into q into delta v upon qb. But it is proton and electron, everything is same. So again the radius is proportional to mass, root, right? Proton and electron is mass of electron, right? It's greater than 1. Again electron is more deviated, right? Copy this. So read this question. In this question, right, 3 charged particle, again proton, deuteron and alpha particle, right? Plus 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 e plus 2e, m 2m and the mass is 4m, you can assume, right? Transverse magnetic field, they are projected in transverse magnetic field find ratio of the following parameter. First, the time period. What is the time period? 2 pi m upon qb or not, you tell? Are projected in uniform, then find circular motion. What is time period? M upon qb. So time period of proton, time period of deuteron, time period of alpha particle. 2 pi and b is constant. So m upon q proton, m upon q deuteron, m upon q alpha particle. So m upon e is 2. 2m upon e is 2. 4m upon 2e. Understood? So this is the answer. Right? What about frequency? Yes. Frequency is nothing but, right, 1 upon time period. So frequency of proton, frequency of deuteron, frequency of alpha is equal to 1 upon time period of proton, time period of deuteron and alpha. Right, time period of alpha. So it is the reciprocal of this. Right. It means it is 1 is to 1 by 2 is to 1 by 2.
Yes.
Right. Reciprocal, and it is 2 is to 1 is to 1. Fine. This is the B part. What about the C part?
Angular frequency.
Okay. Angular frequency is nothing but 2 pi f. So omega is proportional to f. So frequency is proton, deuteron and alpha. Same as frequency of proton, deuteron, alpha. So, right. So proton is what? Say 2 is to 1 is to 1. So this is the solution. Copy this. So read this question. In this question, a particle of mass m, charge q is projected in a region of the perpendicular magnetic field B and width is d. Right? This is the perpendicular magnetic field and its width is what? D. Right. And if this is the charge particle, suppose plus q is moving like this. So it enters in the magnetic field. Right. Now it is deviated. Listen one thing. Although if the everywhere the magnetic field is present, are you getting or not? In perpendicular magnetic field, if the charge particle q enters with the speed v, so magnetic force will act upon this direction. So it will be the direction of the, it will be the position of the somewhere center of the circle, because in a perpendicular magnetic field always a charged particle will perform UCM, uniform circular motion. And if it is performing uniform circular motion, there must be some center of the circle, and it is found at any instant magnetic field velocity, this is the direction of force. So direction of force is always act towards the center of the circle. So it would be the position of the center of circle about which it will perform circular motion. If everywhere was the magnetic field was present, so it will complete the circle. It should complete the circle. It should complete the circle if everywhere the magnetic field was present. Is it clear or not? And the radius must be equal to what? Say mv upon qb. But from this point the magnetic field is present, it is moving in the circular arc, but here when it reached to this point, now the magnetic field is finished, then its velocity will be v, right? So it will continue to move in the straight line. Are you getting or not? Because no magnetic field present, only the width is d, right? So listen one thing. If this angle is theta, listen, if it was the initial direction of the velocity, now it is going in this direction. So what is the deviation? So this angle is the deviation or not, you tell?
Yes.
So suppose this angle is theta, this is the radius r, this is the distance d. So what is the sine theta from here, you tell? Sine theta is nothing but perpendicular upon radius. And what is the d? Radius is mv upon qb. This is d qb upon m into b. Is it clear or not, you tell?
Yes.
Now if it is theta, it is what? It is 90. It is theta, is it 90 minus theta or not, you tell?
Yes.
So this angle is what then? Say theta.
Yes.
Is it clear or not?
Yes.
So this angle is 90 minus theta.
91.
So this angle is.
Theta.
So this is the deviation. So what is the deviation? Therefore, deviation of charge particle. What is the deviation of charge particle? Is theta.
Theta.
And from here it is sine inverse qdb upon m into b. So this is the deviation of the charge particle. If the width d is less than radius r, are you getting? This is the condition only when this width is less than radius r. Is it clear or not, you tell?
Yes.
If width, listen, if d is greater than r, so what will happen, you tell? If d is very much greater than the r, so if the charge particle will enter, so it will complete the circle. Are you getting or not?
Yes.
It will complete the circle
Yes.
like this, and then it will, suppose this is the width d where the magnetic field is present.
Yes.
If d is greater than r, it means this is the radius r, this is the center, and now the charge particle q move in this way. This is the plus q charge, straight line. Are you getting? Then what is the deviation now?
Deviation is
Initial it was the angle,
0.
no,
Okay.
and now it become anti-parallel.
Yes.
So deviation is what? 180 degree. 0 is when? If the charge particle is moving this way, and after this charge parting velocity direction is same. But here the direction of the velocity become anti-parallel. So what is the deviation in this case? 180 degree. If this width of the magnetic field is greater than r, that is mv upon qb. This is the answer only when if d is less than mv upon qb. If d is greater than mv upon qb, the deviation will be.
180.
You understand this?
Yes.
Copy this. So let's see another example. For example, suppose there is a magnetic field into the board like this, right? The magnetic field, there is no magnetic field this side, and here the magnetic field is into the board, right? Suppose the plus q charge is coming with speed v, it entered into the magnetic field, right? So what will be the path or the motion of the charge particle when there is no magnetic field this side, so it will continue to move in a straight line. So when it enters in this perpendicular or transverse magnetic field, so the motion of the charge particle in perpendicular magnetic field is always uniform circular motion, as we know, right? So if it is performing uniform circular motion, then there must be some center of the circle. So to find the position of the center of the circle at any instant of the time, you have to find the centripetal force direction. For example, take your left hand, this is the magnetic field, this is the velocity. So what is the direction of the magnetic force at this point, you tell?
Upwards.
Upwards. So if this is the magnetic force, therefore it will be the position of the center of the circle, and about this circle it will start the circular motion, right? Like this. So it will start circular motion. In this question, you have to find the time spent in magnetic field, right? So you tell me how to do that. Magnetic force, this is the radius, and about this it will perform the circular motion. Is it clear or not?
Yes.
So if this is the center of the circle, right, the radius is r, So you tell me, after this, the charge particle comes out. It is moving in this way, right, with velocity v, and it comes out from the same speed, right? Only the deviation is of 180 degree, and it will continue to move like this. Is it clear or not, you tell?
Yes.
Right. So what is the time spent? Listen, from here to here, right? If everywhere the magnetic field was present, so then it must complete the circle. But from here, A, and then it is B, then you may assume the C. So only the half circle or the half time of period is spent in this magnetic field. So what is the total time of period? Total time of one revolution? Yes, 2 pi m upon qb. All right. But it is performing only the half revolution, right? So therefore time spent will be equal to t by 2. That is pi m upon qb is the correct answer. Is it clear or not, you tell?
Yes.
Right. Copy this. For example, another example, similar type. Suppose this is the magnetic field, right? And this magnetic field is into the board here over here. Now the charge particle, in the previous question, the charge particle was entering perpendicular to this line. Now, if it is v, right, it is entering over here, all right, with speed v. Are you getting or not? And suppose this angle is given as theta, right? So if this is the speed v, again you have to find time spent in magnetic field. Is it clear or not, you tell? Right. Copy this and try. So let's see how to solve this. Listen one thing. As you know, the perpendicular magnetic field, charge particle perform uniform circular motion, right? So tell me, where will be the position of the center of the circle? This is the magnetic field into the board. This is the left hand magnetic field, and this is the velocity. The force is acting, you tell, force is acting perpendicular to the velocity like this. Are you getting? So if this is the instantaneous force acting upon this, so somewhere at this point, the center of the circle will be there. It will be the radius of the circle, and about this, it will perform the uniform circular motion. Is it clear or not? And at this time, when it comes out, so the velocity will be like this. Is it clear or not, you tell?
Yes.
Right. And this plus q will continue to move in this direction. Is it clear?
Yes, sir.
So from A to B like this is the part of the circle. If magnetic field was present everywhere, so it will complete the circle. But here only it will perform only some circular arc of a complete circle, right? So how to find the time? Can you find this angle? Yes, we can find this angle. If this is the theta, right, this angle is theta. So therefore, if this is theta, this angle must be theta. Are you getting? It is theta.
Yes.
It must be theta or not, you tell? If it is theta, it is 90 minus theta, right?
Yes.
If it is theta, it is 90 minus theta. So this angle must be theta, right? Listen, if you consider this triangle ABO, this is the radius r, so it is the radius is also r. So it is isosceles triangle. This distance and this distance are same. So this angle must be also theta. Are you getting or not?
Yes.
So what is this angle made on by this circular arc? Angle alpha. What is angle alpha, you tell? Alpha is nothing but pi minus 2 theta. Is it clear or not?
Yes, sir.
So you tell me how to find the time from A to B in this way, like this, right? How to find the time? Tell me. If it complete the circle, what is the angle made by the radius vector on the center, or the angle made by this particle on the center is 2 pi.
Yes.
So if it complete the angle 2 pi, what is the time? Say t.
T.
For 1 radian, the time is t upon 2 pi. What is the angle made? Angle subtended by this particle on the center is alpha, right? For therefore alpha t upon 2 pi into alpha, right? So this is nothing but t upon 2 pi into alpha. And what is the t? Tell me. T is nothing but t upon 2 pi. What is t? Total time for the complete circle is what? 2 pi m upon qb. So it is t upon 2 pi, 2 pi m upon qb. And what is the angle alpha? Is pi minus 2 theta. 2 pi will cancel out, so time spent will be m upon qb into pi minus 2 theta. Is it clear or not, you tell? So this is the time spent, right, in the magnetic field. In the magnetic field. Is it clear or not, you tell?
Yes.
Copy this. So let's see the another example. For example, suppose this time the magnetic field is out of the board, like this, like this, like this, like this, like this, right? B is out of the board and a charged particle is plus q. It is moving, right, with the velocity v like this, right, and making angle theta. So at this point, this side the magnetic field is what? 0. So therefore it will move in straight line, but it enters over here, right? Suppose this is the plus q charge, it enters with the velocity v, right? You have to find time spent in magnetic field, in magnetic field over here, right? Copy this and try. So let's see how it perform the uniform circular motion in the magnetic field. Listen, tell me, it will perform the UCM, so there will be some center of the circle.
Yes.
To find the position of the center of the circle, suppose the magnetic field is outside, right? The velocity is v. Can you tell me what will be the direction of force, either in first direction or second direction?
Second direction.
Take your left hand. The magnetic field is out of the board. This is the plus q charge. This is the velocity. Tell me, what is the direction of force?
Inwards.
Inwards. So first direction. So it will be the correct direction of the magnetic force. So if it is the magnetic force, somewhere the center of the circle will be this. So and the radius is r, and about this it will perform circular motion, and therefore it will again, listen, it will perform circular motion like this. Are you getting? And it will move out from the right magnetic field, and it will continue to move like this. All right, this is the v. So if this angle is theta, so this is the angle alpha which it is making on the center. All right, so you tell me, if this is theta, right, so tell me, it is theta, it is, tell me, it is, if it is theta, it is 90 minus theta. So this angle is what? Theta. This angle theta. So if you consider this is the beta and this is the angle alpha. Is it clear or not, you tell?
Yes.
If it is theta and theta, so alpha is nothing but 2 pi minus beta.
Yes.
If it is beta, this angle is what? 2 pi minus beta. What is the beta? In triangle AOB. In triangle AOB. Theta plus beta plus theta. Theta plus beta plus theta is equal to what? Say pi. Beta angle is pi minus 2 theta. Are you getting? Therefore, the angle subtended by this circular arc on the center is what? Therefore, alpha is what? Utal 2 pi minus beta. In place of beta, right? This is pi plus 2 theta. Are you getting?
Yes.
So, angle subtended by this circular arc at the center is alpha, which comes to be pi plus 2 theta in terms of theta. So, again, if it complete the circle, the angle is 2 pi. For the 2 pi, the time period is capital T. For 1, T upon 2 pi. For alpha, time period is 2 pi into alpha. So, T upon 2 pi into alpha. What is the total time period? Say 2 pi m upon qb. So, 2 pi, the capital T is what? 2 pi m upon qb. And what is alpha? Alpha is 2 pi minus, alpha is pi plus 2 theta, right? So 2 pi will cancel out, m upon qb and pi plus 2 theta. So in this case, the time spent in the circle is m upon qb pi plus 2 theta, right? Copy this. Wait for 1 minute. Suppose this is the circle. In this case, the motion start from here, right? Suppose this is the circle. So this is the circular arc, which subtend the angle alpha over here. Are you getting or not? So we have to find the time subtended by this part. Are you getting or not?
Yes.
Not by this part. So what is this angle utal? Alpha.
Yes.
Are you getting or not?
Yes.
So we have to take this angle, not this angle, right? Is it clear or not? If
Yes.
you have to find the time period for this small part, so what is this angle? Suppose this is the beta. So you have to find the time period for this beta from here to here. Are you getting or not?
Yes, sir.
Copy this. So in place of this, right, if the charge is assumed to be negative, for example, the charge may be negative. Suppose this is the plus into the board, right? They may give the negative charge. Suppose this is the minus q charge. It is moving with velocity v. Angle made by them is theta. So it enters the magnetic field. The charge is negative this time. The magnetic field is into the boat, right? It is moving with the speed v. Suppose this is the minus q charge. It is moving with the speed v. You have to find time spent, yes, in magnetic field, right? Try this. So let's see this problem. This is the negative charge, right? So when it is moving in a perpendicular or transverse magnetic field, either force will act in the first direction or second direction.
Second direction.
Second direction. Why? Listen, this is the magnetic field, this is the velocity. So if it was the positive charge, the force should be in this direction or not?
Yes, sir.
But it is negative, so force direction will be opposite, right? In this way. So therefore it will be the center of the circle. This is the radius, and around this, right, it will perform the circle like this. This is the minus q charge and it will continue to move. So if this is theta, right, again it is 90 minus theta and it is theta. It is theta. So it is also theta. Again, this is the beta, the angle is alpha. The same angle alpha you will get, right, pi plus 2 theta. So same solution you have to do. For the 2 pi, the time is t. For 1, t upon 2 pi. For alpha, right, same solution you will get, same time, right? So you have to consider whether it is minus q or whether it is plus q. If it was plus q charge, right, so answer will be different, because it will make the small circle in that case. Is it clear or not? Copy this. For example, one more illustration we can take. Suppose this is the portion where the magnetic field is present everywhere, right? And the magnetic, this is the center of the magnetic field. Magnetic field is into the board, right? And this is the radius of the circle is capital R. Is it clear or not?
Yes.
Right. Now assume that if charge particle is Q is coming towards the magnetic field like this. Are you getting?
Yes.
So you have to find time spent in magnetic field, right? By field, by this charge particle, by this charge Q, right? Copy this and try. So let's see this question. So when it enters the transverse magnetic field, right, like this, getting? So tell me, if this is the plus Q charge, it enters over here, so it will start performing circular motion or not, you tell?
Yes, sir.
So if it is performing circular motion, where is the center of the circle, you tell? This is the magnetic field, this is the magnetic field, this is the velocity. So force will be perpendicular to the velocity, either in this direction, in this direction. So you tell me, which direction, first or second, the force is acting?
The second direction.
Second, right. So it gives the direction of the center of the circle, right, like this.
Yes.
It gives the direction of the center of the circle like this. So if this is the center of the circle and this is the radius, so around this, right, this is the magnetic force. Around this it will perform, right, the circular motion like this. All right, it will perform circular motion like this. Is it clear? Tell me, right? It will perform circular motion, and here it comes out from the magnetic field. This is plus Q charge, right? And it will continue to move in this direction. Fine. So if everywhere the magnetic field was present, so it will complete the whole circle. Are you getting? Now only this angle is alpha is performed by this circular arc. A, suppose this is B, this is C. What is the angle made by this arc ABC on the center? It is alpha. Is it clear or not, you tell? Right. So how to find this alpha? Suppose this is alpha, this half angle will be, say, alpha by 2. And if you consider this is the triangle, right, the radius is, suppose this is the speed v, this radius of the circle is capital R, is radius. And what is the radius of this circle made by the charged particle is small r. So what is the relation between r and small r and alpha by 2? You will write tan alpha by 2 is equal to what? Perpendicular upon r. R is the radius. What is the r? What is the radius? Say mb upon qb, right? So r, what is mb upon qb? Is it clear or not, you tell? So tan alpha by 2 is nothing but qb r upon m into b. Is it fine? So now this is plus q plus q. This is alpha by 2 is equal to what? Tan inverse qbr upon m into b. Fine. So what is the alpha? 2 into tan inverse qbr upon mb. Are you getting or not, you tell? Sign. So if it complete the whole circle, what is the angle made by the particle on the center? Say 2 pi. So in 2 pi, when it covers the 2 pi angle, the time period is capital T and T value is 2 pi m upon qb. For 1 radian, the time is 2 pi T upon 2 pi. For alpha radian, the T upon 2 pi into alpha. So the time spent is T upon 2 pi. What is the value of T? 2 pi m upon qb into alpha, right? So 2 pi will cancel out, m upon q into v into alpha. What is the value of alpha? Please tell. Alpha value is 2 into tan inverse, right, qbr upon mv. So this is the time spent, right? Time spent is 2m upon qb, and it is tan inverse qbr upon m into v. So this is the time spent by the charged particle from here to here, right? Copy this.